I don't wanna know, no, 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 who's taking you home, oh, oh, oh. I'm loving you so, 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 so. The way I used to love you, no, I don't wanna know, no, 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 who's taking you home, oh, oh, oh. I'm loving you so, 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 so. The way I used to love you, oh, I don't wanna know. Wasted.
Today in physics, we will be talking about the coordinate system. Now, in a three-dimensional coordinate system, we use 4 units, t being time. This is what a three-dimensional coordinate system looks like, x, y, and z. Now, in this class, we will specifically be using the two-dimensional, which we only use 3 variables. Also, t being time in this one. We also use x and y. On these coordinate systems, we draw something called vectors. Today, we'll be talking about unit vectors, which are vectors with a unit of 1, or a magnitude of 1. X correlates with I hat, y correlates with j hat, and z correlates with k hat. On the coordinate system, the three-dimensional one, this is what it would look like. And on the two-dimensional one, it will look like this.
So, what would you do if you want to add 2 vectors together? Well, you'd set up an equation like this, where vector A, this little sign on the top, means it's a vector, plus vector B, and equals question mark. Vector A in this problem is outlined by 4 I hat, which means that it is moving 4 units in the x-coordinate direction, because I hat symbolizes x-coordinates, and then plus 3 j hat, which symbolizes the y-coordinate direction. So it's moving 3 units up and 4 units left. Plus b, which is written the same way, but it's -1 I hat plus 7 j hat. Now, when you get into the equation, it's really simple. You just set it up like this. You can add the 4 I hat and the -1 I hat together because they're both I hat. So to make 3 I hat, and then 3 j hat plus 7 j hat to make 10 j hat, because they are both j hats as well. That's it.
Now what we're going to do is we're going to do a vector example problem. So let's say Professor Anderson walks 3 units to the east, 2 units north, followed by 1 unit west. So first we're going to start with going to 3 units east along the x-axis, which would be east. Followed, we're going to go 2 units north along the y-axis, which would be right here, ignoring that extra little line. And then we're going to go 1 more unit to the west. Now we can tell that he goes a lot further than he actually ends from his starting point. But if we add together, we're going to go with our I hats, which is going to be a positive 3 I hat in addition to a -1 I hat. And then we also have the positive 2 j hat. So in the end, what we're going to do is we can take the I hats, which have like terms. So you have the positive 3 minus the 1. And so in the end, you're going to have a positive 2 I hat and a positive 2 j hat. So in the end, compared to where he started, he has gone 2 units east as well as 2 units north from his starting position. Ta-da!
And so I'm going to talk about some vectors in trade. So let's say we have vector r. We know that it goes over x units and up y units. So we have that, and we have angle theta. So how do we find r? Well, we can use Pythagorean's theorem to show that x squared plus y squared, the square root is going to equal r. And so we all know this. So now let's say that we have this as vector A and B. So if we find A and B from R, we could use trigonometry to show that the cosine of theta is equal to A over R. And then we simply multiply R over, and we'll get A is equal to R cosine theta. So we can use that to prove A and B. So I'll work those over. And then we can also find theta by doing the same thing with tangent. So we have the inverse tangent of the area. Yeah.
I don't wanna know, no, no, no.